All right, let's continue here, and we're going to talk about the difference between independent and dependent variables. So when we're studying relationships between variables in a study, one variable is the dependent variable, and the other is the independent variable. The independent variable is what affects the change in the dependent variable. So the dependent variable is either explained, predicted, influenced, understood by the independent variable. When we use experimental designs, the independent variable is what we're manipulating, meaning maybe one group gets drug, group A gets the drug, group B does not. They get a placebo. And then we're measuring outcomes on between these two groups. So an example of a dependent variable, for example, you could have dichotomous, meaning yes, no, or binary variables. Like yes, no of an event. Did they vomit? Did they have death? That's an example of a dependent variable that you may read in studies. A continuous variable, which is quantitative, maybe differences in heart rate. Maybe a study of beta blockers in the perioperative period looks at giving one group esmolol, another group no esmolol, and they look at differences in heart rate under a standard anesthetic protocol, or differences in pain scores, which you may measure with like a verbal numeric rating scale. Hey, what's your pain? Oh, it's a 5. Or have the patient fill out a circle on or make a mark on a visual analog scale, and you would measure that amount of pain. So an example here is an investigator reports a positive correlation between blood pressure and age. So what would be correct here? Pause the video and think about that. Does blood pressure influence age, or does age influence blood pressure? Which is the independent and which is the dependent variable? All right, so age would be the independent variable and the dependent variable would be blood pressure. So age influences blood pressure. So a study reports that a saline bolus significantly decreases the time to full motor recovery. We already talked about this. What's the independent variable? What's the dependent variable? Independent is normal saline bolus. Yes, no. Did they get the intervention or not? Dependent was time to full motor recovery, or in which case I would call the outcome. Making graphs. So the y-axis is the dependent variable. In this case, they're reporting median income that is influenced by years of education. Education is the independent variable. So, let me go back. Sorry, I'm trying to get my tools here. So, this is your y-axis. This is your x-axis. So here it's showing years of post-secondary education is positively correlated with median annual income. So it's the independent variable that influences the median income. All right, so then we would go to analyzing the data. So then you're getting through the scientific method and the research process. Your analysis is really going to depend on what your hypotheses are, what your study design is, and what your statistical plan was that you set up at the beginning. This is something we have to have a plan when we go through and design research studies. We can't be doing this stuff on the fly. This is IRBs frown upon that. Peer reviewers frown upon that. You need to have your plan and you stick to it. Sometimes you may do some what we call post hoc analysis, which is really exploratory, but really you should kind of have just like you got to have. I mean, you got to have a plan. So many times we will use what's called descriptive and inferential statistics. So inferential is where we're making inferences from the sample about the population. Descriptive is just what it means. We're describing the the population, or really our sample, and making inferences of the population later on with their inferential statistics. But we're really describing the data using various calculations, graphs, or figures. For example, we may use descriptive statistics, or we're just describing the frequency of age groups or the mean age group. And then the inferential statistics is where we're making inferences and predictions about a population based on the sample of data that was taken from the population in question. So here, I don't want you to get don't get too scared looking at this. We're going to go over many, not all of these statistical tests throughout the course of this, during this class. During your coursework this semester. But the bottom line is your choice of inferential statistical test will depend on the goal and type of data that you collect. And so here's just an example. Graphpad.com is an excellent resource. I pulled this table off their website. For example, if we're just describing one group, we may just be doing mean and standard deviations. You can do medians, you can do proportions. There's some other, what we call Kaplan-Meier, we're not going to get into here. Comparing two unpaired groups, but so on. You can look at these. Some of you may have a little bit more background if you want to Google or look up a little bit more what those mean, but we will go in greater details later on. Finally, you want to interpret your results. Because we want to be able to make recommendations. So this is really the fun part of research. This is where you get to sit down, you have all this data, all these results, you've gotten your precision measures, you've really gotten a very, and you've got your p-values, you've looked at, and you've answered your hypotheses with your inferential statistics. Now you need to figure out, what the heck does it all mean? You need to tell the reader, what does it mean, why you found it, and how can we use it. So you need to answer the what, the why, and the how. That's what a good discussion will do. It will also talk about limitations of a particular study and weaknesses, because every study has weaknesses. So here is an example. Now I didn't pull the whole article, but this is from the one we've used as an example throughout this article. So where they're going through in this abstract and interpreting the results to make recommendations. So you can see here what I've done is I've highlighted. So they said no significant difference was found in, and they list some statistics as well as some p-values here. We talked about that a little bit earlier. So they did not find a significant difference in time to full motor recovery. And then what they did is making a conclusion, interpreting results for the reader. So results suggest no advantage in giving a saline bolus. However, what they found, well, actually this is a study I did with my students, is that we actually were probably underpowered because nobody had ever done this study before. So our sample size estimates at the beginning were our best guess, and many times that's unfortunate. That happens. That's research. It's not perfect. It's kind of muddy and messy. But what we did do is we did a post hoc power analysis and suggested, in fact, we may have needed 200 subjects to actually answer the question that we proposed based on the differences that we found between the saline and control group with this degree of standard deviation or this variability. The other thing we found is there was no differences in complications, which suggests that that it's safe. But we could not conclude, so we could not support, we could not reject what we'd say. Remember, we talked about the null hypothesis would be that there was no difference between the groups. And in fact, we did not find any, but it was most likely because the study was underpowered. I think we did a pretty good job with this particular one because we took it one step further to say, in fact, what we would need to actually do this. And it really was not feasible because there was such a small difference between the two groups that it's really not clinically relevant. And so that's where you can see the what, the why, and the how. All right, there's a few terms you need to use that you'll see when talking about results. The result of a statistical test estimates the probability or the p-value or result occurred purely due to chance. So we usually arbitrarily, classically, we use a 5% a p-value of less than 0.05. That we're willing to take that risk that 5% of the time it's due to chance, not due to what we did. When we say the difference between groups on the dependent variable is statistically significant between the groups, the likelihood of that result occurred due to chance is very small. So we go on to say that the difference was in fact due to the independent variable. However, there always does remain that chance that the difference was there's a very small chance it was due to that 5% chance it was incorrect. So we got to be very, because there's that 5% chance that we got it wrong, that we use terms such as the results suggest, the findings support, and not use the findings prove. Anytime I read that in a journal article on an experimental design, it's something I always it makes my hair stand up, because there's always the risk that we did something else may have contributed, and you had that 5% chance that we made an error. And so that's why we use those type of terms. So just remember those terms when you guys start doing your synthesis papers and drawing your conclusions, that it's not perfect. And so remember those keywords, that the results suggest, the findings support. It's virtually difficult or impossible to really to prove. So here's an example. An investigator found during his analysis that a single preoperative dose of gabapentin significantly decreased post-op pain in the PACU after a shoulder arthroscopy compared to placebo. I made up some scores here, and I said it was significant. 3 plus or minus 1 on a standard deviation versus 6. So but the appropriate way to for the author to conclude would be that the investigator concluded that results of this study. So what he says here is the results of the study prove that a single dose of gabapentin significantly decreases when compared to. That would actually be incorrect. It's wrong. The correct way that you would say that is results suggest that a single dose, and so on. Does that make sense? Okay, good. All right, I want you to pause the video, and then we're going to wrap things up and talk about some misleading statistics.